So we'll just do a little bit of introduction to the panel. We've never done a panel before, but the way it's going to work, hopefully, is these guys will introduce themselves. We've managed to crowdsource some good Docker questions from the HangOps Slack chat. So we went into /Docker and asked them what we should ask them. And then at the end of it, they're going to basically be on stage to answer any questions. And these guys are the authority on their areas. So with that in mind, do you guys want to go this way and introduce yourselves?
Sure. I'm Marcus Maxwell. I work for Contino. We're an enterprise container and DevOps kind of consultancy. So we are also a DevOps Premier partner. So I will be representing the Docker Swarm today.
Hi, my name is David O'Dwyer. I founded a company called Livewire. We're an infrastructure development company here based in London, and we specialize in Kubernetes deployments. I'll be representing Kube today.
Good evening. My name is Martin Lasten. I am not sure where that title came from. Where did you find that?
Sorry.
Anyway, I'm a software developer, and I'm working on basically as a consultant at Container Solutions, where we do infrastructure work based around mainly Kubernetes and Mesos, but also Docker, obviously. And I'm representing Mesos here tonight.
Cool, thanks. So the first question that we got given was, is your platform opinionated or unopinionated? Docker Swarm.
So Docker Swarm, and everyone knows it, that Docker Swarm released 1.12, and that was integrated into the core. So that's actually quite opinionated. But it also brings a lot of nice features for you because you have the same API. It extends on what you already know. So yeah, if we will go with Docker Swarm, it has quite heavy opinions, but the API is very clean, and that's why Docker became Docker and why everyone got on board, because of those APIs and those strong opinions on how you should be using it and how you should be consuming it. That being said, there are like providers like Amazon ECS, so they just go and extend those APIs and consume them. So it's not like a black box. You can still go see it and use it the way you want.
I'd say that Kube does have opinions, but I'd say that Kube has just enough opinion around most elements. So it was around 2 years ago where Craig Box presented at Doxlom at, I think it was Central Foundation Boys. And that was the first time I saw Kube, and that's where he was going through a number of the different types of resources and opinions that Kube had by default back then. And one of those opinions was around the idea of a pod, so this idea of a number of containers being a sort of deployable unit. And Kube by default came in that opinion, and that for me was the sort of, right, that's it, they get it. They kind of understand the types of opinions that scheduler will need to make, and it will need to have by default for it to be usable from an operational sense. And since then, they've introduced a number of other resources and a number of other opinions around how to deploy those resources. But they've also done an amazing job to make Kube very extendable. So there's the third-party resource, which has come in recently in the last couple of releases. And with that is a great example of where you could extend Kube to start to implement your own resource types. So I'd say by default it has just enough opinion, but by no means does it smother you with its opinion. You can still extend it in many varied ways.
For Mesos, is Mesos opinionated? I would say no, not at all. But that said, I do not wish for my worst enemy to write his own scheduler, as we all have learned tonight. So you have to put either Marathon or you have to go all the way with DCOS, and that gives you a completely different answer. I would say Marathon, which is the foundation of DCOS, is a lot more opinionated. It's a lot closer to what Kubernetes is today, and it will come even closer with pods coming out very soon. But the nice thing about having this underlying infrastructure that is not at all opinionated is that you can always fall back to that. So when you have some weird needs, you can fulfill them by going down the level. So yes and no to that question, I would say.
Cool, thank you. So the second question that we got given was, what feature from one of your competitors' platforms would you like to have?
So everyone knows Docker Swarm is quite the most recent addition. There was an old version of Swarm, but they redid it. And the feature set is what I like from Kubernetes. That's why like Pearson decided to go with them, is those like rich features. You have daemon sets, you have replication, you have now pet sets, and they constantly add a lot of features, and that's what I would like to see in the next like 1.13 release. There's many more features coming to Docker Swarm, so maybe at some point we'll have some feature parity across all the other providers.
I'd say from Docker Swarm, the feature I'd like to see implemented within Kube is the zero to dev experience. I think it's one of the things that Docker and Docker Swarm has done a very good job with. But on that note, I will say that Kube has done a lot of work around that in the recent months, releasing Kubeadmin, the Composer project, which has been put on the Kube incubator. Yeah, generally, and the Minikube projects as well is another good example of getting from zero to dev on Kube. But I'd still think that a lot of those changes, Kube have drawn inspiration from the Docker development model. On the Mesos side, I'd say if there's one feature I'd like to see from there, I suppose it would be the sort of large-scale usage case studies. So it's not really a feature, but it's something that Mesos has a lot of these very large scale, large node deployments, and I'd like to see some of those feature in the Kube case study library.
For Mesos, I was from Docker. I would say that the zero to dev workflow is definitely something I would like to see as well. It can be very difficult to get something up and running on your development machine. Even though we have built mini Mesos and things like that, it's not quite there yet because there's basically no difference between a normal Docker and a Docker Swarm. Obviously there are, but from a developer's perspective, it's very, very little. From Kubernetes, is Kelsey Hightower considered a feature?
He is, since he joined Google.
Okay. We'll definitely have a guy like him. It'll be good. He's very good at promoting what you're doing, and I think that's also very important for expanding a product.
Cool, thanks. So, question number 3. What's your favorite feature?
I think the main feature of like Docker Swarm is like everyone mentions, like zero to dev. Like you go learn Docker. You start a single container, then you're like, I want a LAMP stack. And you're like, okay, I'll just go do swarm init, swarm join, bam, you have a cluster, you can add more nodes, you can create, you can use compose, and all that you learn, it just slightly builds upon all that knowledge. So it's like a very nice way to just go, and as long as you don't have this feature request for anything else, that's it. You can even go into production with like what you did in dev, and it's super easily to translate that into prod. So that's my main feature.
My favorite feature, Kube, probably isn't the most glamorous one in the context of Kube. It would be the config map. I think ever since the implementation of the config map resource, it's just made the workflow of implementing containers or deploying containers within Kube a whole lot easier. It's created a nice, very similar patterns for deploying cloud native and non-cloud native applications using Kube. It's a really good single resource of being able to take, say, a resource file, so example, a resource file that just contains key values. So then you've got your main deployment file, which contains all of the definition for running your container, and you can deploy that now in dev, stage, production, and just swap in a config map file for each of those environments that has all the environment-specific variables, which is great. But it also has a feature which allows you to mount the config map onto the file system, which I think is brilliant. So where in situations where you don't have an application that's environment variable aware, you can just throw the entire configuration file into a config map and then essentially mount that on the file system. So it will just appear inside the container on deployment. And I think the versatility of that resource is certainly sped up our deployment of containers for a number of customers over the last year.
It's definitely a nice feature. For Mesos, I would say it's the vendor independence. Last time I tried to deploy Google into AWS, Kubernetes into AWS, it went horribly wrong. I destroyed the cluster. It didn't seem that it was tested that much. I don't know what went wrong. Well, I do know what went wrong, but why it happened is still a bit of a question mark to me. But also that it means that you can deploy it on your local machines. It's very easy to actually get Mesos up and running. There are packages in all major Linux distributions today. It takes roughly 5 minutes to get it up.
Cool. So final one from us, and then we'll open it up, and Lisa's going to run around with a microphone, hopefully. So if you've got a question, raise your hand, we'll bring it over. But I mean, this is the question you guys are probably all wanting to ask. Are you working on interoperability plane, like a kube scheduler plus Swarm plus Mesos, all working together, all existing?
No.
No.
So,
Okay, we'll do middle out. Do you think Docker will do that?
I think Docker tries to have everything and make sure that it's kind of like a Mac. They want to control the ecosystem for their feature set. And as you can see, like a lot of people use Macs, and because you get this experience, the applications are always to the same style, they have the similar feature set, and you really enjoy the experience. And you have to make some choices. If everything was interchangeable, then it will basically, you won't have the same experience because you have too many moving parts. That's like why Docker Swarm is so easy. Like you don't have to bring up an etcd cluster because the raft is inside of itself. So there's so little moving parts, and that's why it makes those decisions. And basically, also Docker is a company, so they're trying to push for like Docker Data Center, which provide more features for you with the same experience. So that's the goal.
if I haven't already used up my turn.
Go again.
I'd say it's a good dream to have, and I think that being able to have that sort of shared resource pool across multiple frameworks would only happen when we have standards. And I think it definitely raised the question around having standards at every layer of the implementation stack. And I think that's something that's been put into the public eye a little bit more over the last couple of months. There's been a couple of conversations on Twitter that we've probably all been quite aware of and enjoyed, which has started to ask the questions around how we start to manage standards in this space. So yeah.
There was a client approaching us some time ago about running Kubernetes on top of Mesos. The answers, yeah, we did laugh as well. We were actually wondering how many layers of various orchestrators can you run on top of each other before you bog down the machine.
You could also run it on Google Cloud and then have all of those hypervisors and layers as well.
Yeah, yeah, and then you can probably run Chemo as well. That would also cost a lot. Yeah. No, so we we did ask Mesosphere about, because previously there was support for Kubernetes, and I think they realized it wasn't good enough, so they removed it from the DCOS universe, and nobody has picked it up ever since. So I think there's a reason for that. If you want to offer your teams both Mesos and Kubernetes, you might as well just run two completely different clusters. Run small machines, whatever, to keep the cost down. I don't think it's worth it to do. So,
I think it was also one of those things that there was a bit of a fad at the beginning of the year where everyone was saying how they could run everyone else's scheduler. So it was like Kube could run Mesos and Mesos could run Kube, and then Docker Swarm came along and ruined it for everyone.
That's cool. Okay, so we're out of questions. Thank you to the panel, but we do want to open it up to the floor as well. So can I grab a mic? Sure. Can you guys share? Yeah. Lisa, so.
Thank you. You present a quite different system. It's practically very difficult to compare them directly. So the question is, how are you positioning your system in relative to another from a high availability point of view? Thank you.
I think Docker Swarm, and the same will be for Kubernetes and actually for Mesos, is the high availability is actually quite easy as long as you don't, like, your DNS doesn't fail over. All of them pretty much depend on the raft mechanism. All of them are pretty much backed by etcd. All of them try to communicate. Kubernetes has masters. Docker Swarm has everything built into the Docker engine. So all of them, I think, on high availability are okay, and there's not much to worry there as long as you have enough replicas and masters.
Yeah, I agree. I think the user story is very similar for each. My understanding is the user story is very similar for each product. I'd say that it's actually, this is probably one I ask you, is that with the Mesos, there's a number of different sort of components that need to be put into play that are not necessarily all part of one system. So do you have to HA each of those components individually, or is there a general sort of wrapper for having a sort of master collection for each?
So in a high availability cluster, you have 3 masters at least, and they, in between themselves, they will select the leader. If you're using DCOS, there's a DNS record for finding the leader, getting to the leader at least, and you can just ask any one of them; it'll tell you who is the leader.
Yeah, so it's very similar for Kube. Essentially, you've got 3 main. Well, it's 4. You've got your etcd value store, which is, if you're doing HA, would be a separate cluster. I would recommend a separate cluster. When it comes to Kube itself, you've got the schedule manager, the controller manager, and the API. The API is stateless, so you can run that across multiple servers and send queries to that. But when it comes to the schedule manager and the controller manager, those are stateful. But from early 1.0 release, Kube implemented a additional, like a helper container called Podmaster, which handles the master election of those across multiple systems. So essentially it puts a TTL value entry into etcd, and on the TTL expiring, it will automatically elect another master system to take over the roles. But I know there is a lot of work going on at the moment within the HA SIG group to make it so that, to essentially remove that mechanism so that they can remove as much state as possible and make the failover as easy as possible.
Next question.
Thanks. which one of your platforms has the best enterprise security model?
Mesosphere has DCOS Enterprise, where you can get enterprise support, if that's what you're asking.
More around security, I think. Enterprise security model. Which one's the most secure?
Well, I'm not the one to answer.
Well, I'd say that there's no surprise that there are a number of companies that spawned around Cube, and one of the three leading features they sell are would be the security scanning of the container system. It would be the UI, and the last would be the authentication authorization layer. So I think by default, that was something that was certainly lacking within Cube. It was not something that was like at the forefront of the development model. But because they've essentially mirrored the service account model that they use within Google Cloud, they know that they have the sort of architecture to do that. It was, I think, from their perspective, it was a matter of when to start heavily pushing that model. So I'm confident over the next couple of point releases, or I know in the next point release, 1.5 release, we're going to start to see more work around service accounts, more work around new types of resources and policies associated to service accounts, etc.
So there are like many layers for enterprise features. So your security team might say there has to be TLS end-to-end and inside of the cluster. So Docker Swarm gets you that. It's quite easy to get everything, all communication, TLS. For advanced features, so let's say you want RBAC control, that's a very popular one. And if you want like security scanning, Docker has their own products for the enterprise. They have the Docker data center and the control plane, both of them. And they also have the Docker trusted registry, and you can sign your images and you can verify them and scan for anything malicious. RBAC control is also built into that product. So that's why enterprises go for that thing. Docker Swarm itself is quite early days. So features like service accounts, I'm hoping, are coming also.
We have a question over here.
All three containers and container management seem very generic. Do you think there's anything in particular which you think is a outstanding quality or feature that you think you have?
Your differentiators, I guess, your unique selling points.
So Mesos doesn't necessarily have to be containers. It can just be a CH rooted sandbox environment, which isn't necessarily containers.
I'd say the varied and width of the resources available, so the feature set that's available. But then I'd also say that the community support is something which is key for Cube. I feel that it's two sides. It's the community and the enterprise support. So on one hand, you have a very wide and very open source community, a very active Slack channels, very active special interest groups. On top of that, you have a very open platform for discussions around new features, roadmapped features, a very good process for promoting proposals and promoting them into feature releases. And on the other side, we have, I think, an enterprise ecosystem which is very healthy and which keeps everyone on their toes, but in a nice competitive way. So I think having companies such as Deis, having companies such as Red Hat, which have their own requirements, and Rocket, I think it keeps everyone on their toes, and I think it balances off nicely that a number of the larger interest groups and the smaller interest groups get represented.
For Docker Swarm, like I mentioned before, is the dev to a prod experience, because that's what pretty much was promised in the container world, that you created your container and now you can easily run it anywhere you want. And that's pretty much the way you run it is also the same. And that's like the main differentiator. Regarding feature parity, I think both Mesos is now trying to catch up with some Kubernetes features. and all the auto schedulers are also pretty much doing the same. So it's more like a waiting game, and if you ask the same question like a year ago when Docker Swarm was not released, it will be a different conversation than we have now. It will be a different conversation if it was like Kubernetes 1.1 when there was a lot less features than like in the latest 1.4. So it all depends at what point in time you'd want to describe the feature set.
Hi. Touching a bit on the feature roadmap for all the three platforms. We've recently heard about the project or the tendency or the idea of forking Docker for a different development stream. We've all seen where the container is now. It was the infrastructure as a code a couple of years ago. Where do you see your platforms going down in terms of development and further release cycles for the future? Where do you see it going?
Is that so? You're saying just the further development of the individual platforms, or development on the platform? Sorry, both.
Of the platforms themselves, but also of the communities from where you think the communities want to take the platform.
I think at the moment, as I alluded to earlier, that because I honestly feel that Kube is at the moment is very community driven. And I think there's a number of the more Google opinions, I'd say, are set. They're there. That's what basically entered the 1.0 release with these primitives that came out of their experiences of maintaining and building Borg. I think now what we're seeing are real world requirements coming in. And I think config map is an example of one of those. Ingress controller is a really good example of another. These are features that solve real world problems, and these are not necessarily features which benefit Google's cloud, you know, because ultimately if they wanted you to only use their system, they wouldn't have put ingress controller in. They would have just said, oh, just use an external service with a load balancer and don't worry about it. So I think what we're seeing now is these sort of new heavy community-led features. Federation. That's a big feature. You know, the ability to essentially leverage across multiple providers, which is what we were hearing earlier on for Pearson. The ability to distribute across multiple providers, not having that vendor lock-in that would normally be what you could have, say, earlier on in the development of Kube, say that's what they're aiming for. You can't say that now. I don't believe you can say that now. So yeah, I feel that it's the transparency of the community. Is there, and the long-term roadmap is another point, actually. So one of the big criticisms for Kube around the 1 release was there was a bit of fuzziness around where it was going long-term. So what's going to come up in the next release, what's going to come up in the release afterwards. And they brought on board last September, they brought on board a community manager called Sarah Novotny, who has done a wonderful job with getting everything in place. And she's done this wonderful job of essentially working with the community to get this roadmap, to get the special interest groups together, to get that transparency going. So really the question from a Kube perspective of where it's going to be going in 6 months, 12 months time, just go onto the milestones on the GitHub, go into the weekly community chat on a Thursday, which is 6 p.m. At the moment, London time, go into special interest Google groups. It's there.
For Mesos, it's mainly focused around DCOS and hardening it, especially UI. It kind of needs it, and then they are working on implementing a pod-like structure as we have in Kubernetes. Those are the main things I've heard about that are coming up.
For Docker Swarm, it's also pretty much the same, catching up with the feature sets, making the experience still be the same as polished. And then I think there's a lot more additional kind of features that developers would like. So like, I think the same can be said for like Kubernetes and Mesos is once you get it out of the box, you have a very nice like scheduler and you can do a lot of work, but in terms of operations, the feature set is usually still not there. So what I mean is like very nice logging infrastructure, very nice dashboards and some monitoring, some out of the box that you can see what you have when you launch this platform.
Out of the three products, which one is less prone to bugs? And when bugs are found and reported, which one tends to get them resolved the quickest?
So I think Mesos is the one that has been around for the longest. It's been working in Twitter's production environment. I think that's hardened it a lot.
I was going to say it's very difficult to comment on the other two products and how Cube is relative to them. But what I will say is one of the other things that's happened over the last 6 months is the end-to-end testing has, I believe that the end-to-end testing model, or just the general development model of the Kubernetes on GitHub is brilliant. And I've always held it up as a sort of standard for how those sorts of projects should be run. But one of the things that did let them down was the breadth of their end-to-end tests. And this was one of the sort of big sort of Google criticisms going into this year, was that the end-to-end tests were very Google Cloud-centric. There wasn't nearly enough AWS coverage, and AWS being one of the primary destinations providers. And I think what you alluded to earlier on about the Kube scripts, the like Kube up scripts breaking, that should never happen. That should never happen. And it was happening simply because they never had the breadth of providers to essentially do this. And I think they were a slight victim of their own sort of hands-off approach, where they cut it loose. It's an open source project. Google weren't going to come in and provide this AWS infrastructure. It was something which either another company needed to do or the community needed to do. And I know another large tech company came in and donated a rather large AWS cluster to do this. And I know another, recently in the last 2 months, another provider has offered up a large vSphere provider, which is why we're now seeing huge changes in the vSphere support for Cube, some really good changes for vSphere support in Cube. So I'd say the end-to-end tests now are very, very solid. The community is very active. They have some very, very good developers with some very hard opinions on code practices, monitoring the, I won't drop any names for fear of reprisals, monitoring the issue queues and monitoring the code commits. So I think the quality of the code has increased, and also the turnaround time with the end-to-end test is shortening.
Regarding Docker Swarm, I think both Kubernetes and Docker are written in Go, and the nice feature of that is it's easy to contribute if you want, but they're also on GitHub, and that's the main feature that I like on both projects. I don't know if Mesos is. So you just go, if you ever hit an issue, it's easy to find the error. You go into GitHub issues, you go follow the thread. Usually if it's critical, there's always a bug fix, a .release. That's pretty much all. There's always .releases in Docker. If there's anything else, it will be put on the roadmap and get promoted. And in most releases, I think there wasn't that many features that anyone requested in Docker that weren't like quickly iterated upon and delivered. And if not, there's an early, it will be told in the tickets, like, we're not doing this for now, you have to wait. And that's pretty much the working model for a lot of open source actually projects now.
Thanks. I want to ask you, if you look at it in a different level, more in a business perspective than a technical perspective, so you have to make a choice of one of those products based on a budget for applications that are already running on Docker, for example. Like you have a dozen applications that you want to get all the buzzwords implemented with one of the products, but you have to take into consideration how long it takes to train your team, maybe get some more people, how easy it would be to get new people for each of the products. If you put all in the money that you would spend to get within, like say, 6 months or a year to get into a good state, which product would you choose? Even though you might say, oh, some products have a lot of better features, but you could spend a bit more money versus others that you'd have to implement some of those features yourself, and those taking a lot longer. So on the business perspective and the money perspective, which one would you choose?
I think that's like being a consultant. It depends, but you have to look at your team size and the growth, and is it a very brownfield project or a greenfield project, and what you can do. For now, and if you don't really want to spend money on Docker data center, for example, for small to medium, Docker Swarm is super excellent and super easy. Regarding feature sets and deciding upon that, and if you would like to build more features into Docker Swarm, something like that, I usually tell any client that thinks that, unless you want to contribute and have a team there, is that your business goal for now, or do you have something else worthwhile that you can do now in the meantime? Because what I found from the evolution of all these schedulers is if you wait 2-3 months, the feature is going to be there, it's going to be maintained by those teams, and there's no reason to reinvent the wheel for yourself and create debt.
I would say it's a journey. Obviously, you want to write a few microservices, put them into a Docker image, and deploy them on a server. If you're just running a single, just a handful of applications, you might just run it on a single server. And then over time, you'll probably realize that things start to break. You need to keep that server up and running, and that's when you have to start to look into orchestrators. But by that time, you'll know a lot more about your application, what type of needs it has, and I'll say at that time it's a lot easier to choose an orchestrator. I won't necessarily do it from day one.
I'd say from a business perspective, the choice of scheduler is, that's way down the line. I think the first thing you have to look at is the applications that you're working with. Are they cloud native? Are they containerized? Are they in a position that you can transfer them into containers? How is the configuration set? How is looking at your data? How is your data managed? The persistency of your data, the statefulness of your data. My point is there's a lot of questions that need to be answered from a sort of total cost perspective of going on what you were saying, like a journey into using one of these scheduling solutions. I'd say that each of these products has a different way of maybe helping and enabling you or simplifying ways in which you onboard those applications, but that's where a lot of the graft is going to be initially. Then secondly, it's going to be the same across all these products. There'll be a sort of management overhead of how do we translate our old processes and tools into this new world of containers. So we have our old Nagios system, and now we've got to move to our new data loop system, which manages containers. And so how do we do that? How do we work with this tool? How do we work with our deployment pipeline? How do we work with our build pipeline? These things are completely agnostic from the scheduler themselves, but these things need to be answered from a business perspective. So I'd say when you actually get to a point of understanding your application better, understanding the needs of your application better, understanding the needs of your departments, how they're going to interact with the cluster, I'd say you've got a lot of really good questions that will help you narrow down the choice of scheduler at that point.
I'm new to containers, and I understand there are some workloads, particular workloads, where containers shine and deliver benefit. What if I wanted to run back office infrastructure on containers? Do you think it's already time for that?
Depends. If you're talking about your big Oracle database, I'll say no. I think Jira is put into a container.
We run Jira on our Kube cluster.
And are there benefits? Is it more work than it's actually work for the back office? Because I can understand one monolithic
it's very popular to just, for example, if you want to bring up Jira or Confluence manually, you have to install Java, you have to have this much RAM, you have to go, click the links, go everywhere. It's a mess. You can just go to Docker Hub, go bring it up, and that's it. So Jenkins, Jira tool, Jira, Confluence. Even like I often see now where it was very popular to have this laptop scripts where you bootstrap your laptop, you will just have like Docker containers for your small apps, and that's how you will be building your pipelines and everything else. As long as the app is like you can containerize it, it's fine. Probably like some very ancient software, don't do that.
Just add in, essentially it's similar to what I said before, which is if it's just one application, there's a lot of overhead. There's now a lot of overhead in learning how to build good containers, how to deploy those containers, what to do if the master server goes down, what to do if one of the there's a lot of overhead. So if you're talking about one backroom application, then probably not. But if you're talking about having like 50 different applications of different types of dependencies, then suddenly, yes, it does actually start to make sense, because now you have a common platform which you could then commit change, process change, update, have one method of updating servers, one method of managing applications, one method of monitoring. So it really is an IT/business decision on when the sort of overhead of learning and implementing a scheduler such as ours outweighs the day-to-day struggle of actually having to maintain the current infrastructure.
All right, last question.
Over here.
You can always ask any more questions down the public.
Hello. So to build a prod like POC, how many nodes do you need to have to do that? And are there any gotchas when you're doing a POC on your products?
What do you want to achieve in your POC? So,
well, a production representation of what I'd need to do. So, like, can I run everything on 3 nodes, or do I need 20 nodes to build like a Kubernetes?
How many nines do you need?
Sorry?
How many nines do you need?
Let's go with 5 nines.
I can make it as reliable as you want, but it'll cost you. I think it's just a question of, it's a tool like any other, like any infrastructure tool. If you were going in and building any other infrastructure, you need to start to look at the components from an availability point of view. Kube is just, if you're using Kube or any of the other schedulers, then it's just other areas that you're looking at. It's different challenges with each of those technologies, but the questions that you ask yourself are still the same around, do you need availability within a region? Do you need provider availability? Do you need, those are the questions which will drive getting a piece of paper, working out exactly what you need available when, and only then when it's on paper, because paper's cheap, that you then start pushing that into, okay, which one of these solutions will enable me to reach that end goal in the most cost-effective way for my applications and my business. And it may be that it's Kube, it may be that it's Docker Swarm, and it may be that it's Mesos. But I think you need to go through that process of understanding your application and what you're trying to achieve with it in terms of availability and cost constraints before you could review each of us.
Sorry, add on, as you mentioned POC, what I thought was something like, you want to get ELK up, put everything in one server, and it just works. But you're obviously not going to run it that way in production. But you can get a big POC with just one server very quickly doing that. If you pick up all that question and say, okay, if I want to try it out in all of those products just to see which one is better for my application, how quickly would that be, how easy would it be, and how much would it cost me just to get that small POC done? For a client, for example, to showcase all the products?
Again, I'd say it's dependent upon the product. So if you've got something like Cassandra, which can run in a single node, local, what you call like a host path in Kube, where you're just essentially rendering out the data to a local directory really quickly. But then the time to convert that into a production-ready cluster is obviously quite large. Whereas if you've got something like Redis or Memcache, which is just memory persistent, then you load up one Memcache server, there's that. Now, I'm not saying it's as simple as this, but a lot of the, to go from that to a highly available situation, you're just spinning up the replicas from 1 to 6. There's obviously going to be configuration settings, there's going to be other things, but generally you're getting 90% of the way there of making it highly available just by spinning up more replicas. So it is very application dependent.
To avoid watching vendors squirm a little bit more, our answer is 12.
That's cool. Thank you.
3 TCD, 3 minions, 3 ingress, 2 auth, 1 master.
Cool. Okay, that's it. Thank you.
Thank you.